Hi, my name is Michael Chi, Product Manager at Matrox Imaging located in Montreal, Canada. We're here today at the Matrox booth at Vision 2010. Me and my colleague will show you the demos that we have at our show. First, we have the Matrox SuperSight, our high-performance computing platform. We have on demo, what we have here is a printing inspection done on the SuperSight. So now you take a look at the high density that we have inside the machine. We have 3 system host boards here. What system host boards are essentially individual PCs. Each of these are running dual quad-core Xeons from Intel. At the same time, you can also fit GPUs from AMD or NVIDIA. We're compatible with both. And finally, we have a frame grabber, which is the Matrox Radiant inside the system, all connected to the PCI Express 2.0 backplane. Now, in terms of processing, we do this in clusters. In this machine, we're using 2 clusters, one with each a system host board and a GPU for each cluster. In terms of processing that we're doing on it is we're using our Matrox Radiant to grab, do a simulation of a grab inside each of these host boards. This grab is doing at 120 frames per second, each with 2K by 2K images. So essentially, we are grabbing at around 1.5 gigabytes per second of data, round robin into each system host boards. From there on, we're doing image processing, a printing inspection. So essentially, we're matching a template into live images and finding defects into it. The first part of this inspection is done through the system host board. From then on, we transfer the image into the GPUs. And then inside the GPUs, we do finer detail inspections, find the defects, push the image back to the host board to do the blob analysis at the end to find the defects. And what's really interesting about the Matrox SuperSight is the connectivity between each of these devices. So again, they're going through a PCI Express 2.0 backplane that could generate theoretically 8 gigabytes per second of data transfer between each device systems. Now I'd like to show you our second demo here available at the Vision 2010. The hardware here is the Matrox Orion HD, a HD SD capable graphics adapter and grabber board that we have on display here. Now this card is capable of accepting DVI, SDI, or even the HDMI or VGA adapter in display or input. Acceptable formats for the input and output are up to 1080p 60 frames per second. At the demo here today, we have 2 different cameras, a full HD 1080p 60 and a 720p 60 camera grabbing at the same time into the Orion HD and at the same time displaying onto 2 different displays. So that's one of the capabilities of the Orion HD, dual input and dual output capability. And along with that, we added effects to the image, which is also done by the hardware of the Orion HD. Here we have the Matrox Imaging logo and a picture-in-picture format, which is essentially displayed from this camera into here. At the same time, there's alpha blending, meaning it's blended into the image so you can see the background of it if you take a look. Finally, the last effect we added with the hardware of the Matrox Orion HD is MIM warping. So we're allowed to do all this with almost zero CPU usage on the Matrox Orion HD.
Well, thanks, Michael. My name is Peter Borriero. I'm the product line manager at Matrox Imaging. And I'd like to show you a few more demos that we have here at the Matrox Imaging Vision 2010 stand. Let me begin by showing you a demo that we put together hardware-wise based on our Gator Eye Gigi Vision camera. We're using the color model here. It's connected to a Matrox Foresight X industrial computer that's embedded in the demo station. What the demo was put together using our Matrox Imaging library, using the latest update, which is called Processing Pack 2. What this demo is showing is the ability to do histogram-based color matching. So the demo works by first locating a fiducial using our pattern matching module, then using our new fixturing capability, placing 4 regions where we will perform the color matching. Now, what's interesting about histogram-based color matching is that it's good for multicolored regions. So what we're doing here is inspecting for the distribution of candy. So we have an expected mix order. And what we've done, some of the sample sites, we've mixed the order or we replicated some samples. So we're able to detect the wrong mix of color. So another demo that we have here at the Matrox imaging booth at Vision 2010 features our Matrox Iris GT smart camera running the Design Assistant software. Specifically, Design Assistant, the Design Assistant software is an interactive development environment whereby you develop your application by designing a flowchart, as you can see over here, as opposed to writing traditional program code. In addition to designing the application logic, you also are able to design the operator interface that will run on the camera within the same environment. So here, moving on to the actual running demo, we're showing ampule inspection, and specifically all the tools that can be deployed onto the Iris GT smart camera. Here we're detecting for fill level, the alignment of the nozzle, is it straight or is it crooked? And we're also looking for the presence of the cap and if the cap is inserted correctly. Here what you see here is the screen is interfaced directly to the Iris GT camera. So theoretically you don't need to have a PC to view the operator interface from the Iris GT. It's actually a touch panel, so I can actually interact with the interface directly. Resume inspection, for example. One of the interesting features of the Matrox Iris GT is that you can have multiple connections to the camera for the operator view. So you have one here, and if we move here, you see you also have remote connections to the camera. So you get to see the same operator view as it's running locally on the camera, remotely. So I can see it here through a web-based interface. So it's the same web pages that you saw just before, or you can access it from a .NET-based application. So here you see the interface to the camera's operator view not from a web page, but actually from a .NET application. So you have many options for publishing an operator interface with the Iris GT smart camera. So the last thing we'd like to show you here at our booth at the Vision 2010 show is a preview of some technology that we're working on. It's actually an enhancement to something that we already have available. It involves positioning objects in 3D space using a single camera. So here we've calibrated the system. I'm not showing this here now, but what we can do is with just 4 fiducials, we're able to position an object in 3D space. In this case, it's a model car, and as you can see from we're following the wireframe of the model car. So we just need to locate 4 of the multiple fiducials here in the camera's field of view in order to position the object in 3D space.